The topic that I will be teaching you is z-scores. And you might ask, well, what are z-scores? And z-scores are actually standardized scores. And z-scores involve standard deviation. And a quick definition of what standard deviation is just the general distance that values in a dataset are away from the mean. And to put z-scores into perspective, let's say on my AP statistics test, I scored 90 out of 100 points. And let's say my AP statistics teacher calculated that the mean or the average score was 85. And let's say she also calculated that the standard deviation or the typical distance that values in a dataset are away from the mean is 5. And to show you that this works, let's go back to our previous problem where my value was 90, my mean was 85, and my standard deviation was 5. And now we just plug in our known values. So my z-score is equal to 90 minus 85 all over 5, which is equal to 5 over 5, which is equal to 1. And that equals my z-score. And to verify that this formula is correct, here is the formula given in the textbook. And one way that z-scores are related to my life is through test scores. And so, for example, on the math section of the ACT, I scored a 31. And if I wanted to find the z-score of my math score, I can go on the ACT website and find that the mean that they calculated for all test takers is 20.9, and the standard deviation that they calculated is 5.3. And now I can use my z-score formula to see where my math score is located in the distribution of the dataset. And that would be my z-score is equal to x minus the mean divided by the standard deviation, which is equal to 31 minus 20.9 divided by 5.3. And now we can calculate my z-score, and that gives me that my z-score is approximately 1.91, and that tells me that my score of 31 is approximately 1.91 standard deviations above the mean within the distribution. And z-scores are important in the real world because they give you more information about the values in a dataset. And an example of this would be, let's say, someone scored 50 out of 100 points in an exam. And one might think that this is a bad score, but let's say that the mean for the class was 10 points, and standard deviation for the class was 5 points. And if you calculate the z-score for 50 relative to the class, you would see that this score of 50 is actually pretty good. But let's say in a different class, someone scored 90 out of 100 points. One might think that this is a pretty high score, but let's say the mean is equal to 97 and the standard deviation is equal to 1. You would see that this score of 90 is below the mean, and if you calculate the z-score, it would be negative. And that shows you that this score of 90, while it looked good originally, if you compare it to the whole data set and you calculate its z-score, is actually a pretty bad score. And Z-scores give you a better sense of the distribution, and that shows why Z-scores are important.